This is Atlas Launch Control at T-minus 41 minutes and counting. We are on schedule for the launch of the United Launch Alliance Atlas V rocket with the orbital ATK Cygnus cargo resupply module. Launch continues to be scheduled for 11:11 a.m. Once liftoff occurs, it will take the Atlas 21 minutes to place the Cygnus in the proper Earth orbit to rendezvous with the International Space Station. This will be the 71st launch of the Atlas V rocket in the long and storied history of the Atlas. This is a commercial mission by Orbital ATK under a launch agreement with the United Launch Alliance as part of NASA's Commercial Resupply Services contract for the space station. Work to fuel the rocket with the liquid oxygen and liquid hydrogen began at 8:41 a.m. this morning, approximately 2.5 hours before launch. We'll enter a final planned 30-minute built-in hold just before 10:30 this morning, shortly after which the Air Force Launch Weather Officer will be giving a final weather briefing. And we'll look now at some of the rollout of the Atlas V rocket from yesterday morning, about 9 o'clock. The Atlas V with the Cygnus payload is 191 feet tall, 2 stages plus the payload. The payload fairing enclosing the Cygnus is 14 feet in diameter. The Cygnus module has a diameter of length of 21 feet, and it's 10 feet in diameter. On board, the Cygnus module is 7,626 pounds of cargo going up to the International Space Station. Meanwhile, the RP-1 propellant loading was completed yesterday afternoon, 25,000 gallons of RP-1, and liquid oxygen is loaded aboard now, about 4,800 gallons of liquid oxygen, and all of the countdown activities are continuing ahead on schedule for our 11:11 a.m. liftoff. At T-minus 38 minutes, 8 seconds and counting, this is Atlas Launch Control. This is Atlas Launch Control, T-minus 36 minutes, 5 seconds, and counting. NASA's pleased to announce today that for the first time, you can view this rocket launch in 360 degrees. This is not just for our virtual reality viewers with the 360-degree headsets, but for anyone interested in gaining a panoramic view of the launch straight from their own smart device or personal computer. You can manipulate the video on the screen, virtually placing you closer to a live rocket launch with a 360-degree view just a few feet away from the rocket as it's lifting off. So, to view the stream, go to www.youtube.com/NASA Television and then click on the associated Live Now link, and that will take you to the 360-degree virtual reality view of the Atlas V. All of our activities continue on schedule, not working any weather issues either at the moment. So we're now at T-minus 34 minutes, 51 seconds and counting. This is Atlas Launch Control.
T-minus 34 minutes.
Roger. Field 2, resume Centaur LA2 topping to flight level.
Roger.
Box 2, resume Centaur LA2 topping to flight level.
Roger.
T-minus 32 minutes.
This is Atlas Launch Control, T-minus 31 minutes, 10 seconds and counting. Joining us now is Frank DeMauro, the Vice President and General Manager for the Advanced Programs Divisions for Orbital ATK Space Systems Group at Orbital ATK. And Frank, would like to welcome you because you can kind of walk us through what we've done to get the CRS-7 Cygnus module ready for flight today. First of all, tell us a little bit, anything unique about this particular module compared to ones that we've launched previously.
Well, this is the fourth mission of our enhanced Cygnus vehicle, so it's very similar to the ones we launched the past three missions. In this particular mission, we've actually added more science capability, so we are actually carrying additional powered payloads for NASA. So once they're loaded into the spacecraft, we actually have power that's supplied to them so they can run their coolers or their freezers. It keeps the test samples fresh for the duration of while we're in Cygnus, and then up until we get to the ISS, where the crew will take them off the spacecraft and start running the experiments.
Well, we have some video now of what we've done for the Cygnus module in the processing to get it ready to fly. So if we could go ahead, run the video, and Frank, you can tell us what we're seeing.
Sure. So this is when we shipped the cargo module from its facility in Torino, Italy, to the launch site. We actually shipped it directly from their factory to the launch site. It actually doesn't see the service module until they come together here. Here we're unpacking it from its shipping container. Once it's unpacked, it'll get placed on its ground support equipment, sort of a holding mechanism. And we'll run some initial checkout of the cargo module, make sure that it survived the shipping perfectly fine. And then once it's been checked out, we'll begin the process of loading the cargo. Here's the service module arriving from our facility in Dulles, Virginia. After it's completed all of its testing at our facility, we ship it to the launch site, and we actually do some initial checkout of the service module on its own to make sure it survives shipping perfectly fine. Here you can see our team is loading the cargo. The actual first piece of cargo we load is the Sapphire experiment, which is the third time we're flying that experiment for the NASA Glenn Research Center. That's installed first. And then the remaining cargo of what we call the initial load, which is roughly 3/4 of the total cargo, is loaded into the cargo module. Once that's complete, they'll transition the cargo module from horizontal to a vertical configuration. We do that so that we can prepare it to get mated to the service module. That's all done with the cargo module and the service module in a vertical configuration. So once it's vertical, the team will attach it to its lifting fixture. It will eventually be lifted off of its ground support equipment and then shifted over by crane. You can see the service module over to the right side of the video. Here we're lowering the cargo module onto the service module. There's mostly mechanical hookups that occur. Once that's done, we'll check out the spacecraft at what we call the Cygnus level, because it's now a completed spacecraft. We'll eventually bag it for transport to the fueling hall. Here they're lowering the completed spacecraft onto the K-MAG, which is the motorized transport vehicle. So we'll move it over to the PHSF, which is where we load the hydrazine and the oxidizer onto the spacecraft. At that point, we will transition the spacecraft to be horizontal again, load the remaining cargo, and then it will be encapsulated into the fairing, which has happened here. Once we're inside the fairing, we'll get back on the K-MAG, and we'll get rolled out to the vertical integration facility, where it'll get hoisted up high and mounted on top of the Atlas rocket.
Frank, there's something special about this cargo module and also what the astronauts will see when the cargo module is open. Could you tell us a little bit about the dedication to this module? What makes this a little bit special?
So all of our modules, all of our missions, we've dedicated the spacecraft to an astronaut who's left us. In this particular case, we've had the honor, and we are humbled to name the spacecraft after Senator John Glenn. So we are now flying the SS John Glenn to the ISS today. It's special for our team. Senator Glenn is such an inspiration for so many people in the space industry, and especially for the astronauts, not only at Orbital ATK, but around the world. So we're honored that his family allowed us to name the mission after Senator Glenn.
I guess that's what the crew would see when they open the hatch.
Once they open the hatch, they'll get the hello and Senator Glenn's picture. So we're sure that's going to be a special moment for the crew.
Well, Frank, thank you very much. And we're looking forward to the launch as well as the activity when it rendezvous with the space station coming up here in a couple of days as well. So thanks so much. And we appreciate having had Orbital ATK with us for the missions that we've launched here from Kennedy Space Center in Cape Canaveral, because it's been a very rewarding relationship, I think, for us as well as for Orbital.
Well, it's certainly been special for us, and George, on behalf of my team, I want to congratulate you on your upcoming retirement. We are really pleased that we were able to be part of this mission, and so we thank you for your great service to NASA and the nation, and being the voice of NASA. So thank you very much.
Well, it's been fun to work with Orbital, which goes back, quite some ways. In addition to the cargo modules and the space station work here, it goes back to our Pegasus launches with Orbital. That's as right. Well. That go back our first launch out at Vandenberg quite a number of years ago. So it's been fun, and it's good to see a lot of the same team is still with us.
Yep.
So.
Very good.
Frank DeMauro, our Vice President General Manager for the Advanced Programs Division for Orbital ATK Space Systems Group for Orbital ATK. And we're now at T-minus 24 minutes, 46 seconds and counting. This is Atlas Launch Control.
Leakage vapor evident at the LOX dump pond. Team evaluated that and has been monitoring. Appears to be a short-term observation during the initial phase of this loading. We had some possible locks in that, but it is cleared. It is not continuing. The team is evaluated from all fronts, and we have no issues with proceeding. Recommend proceeding.
LC concurs. LD.
LD concurs as well.
Prop 1, LC, net 1.
Go.
And you copy that anomaly team recommendation.
Roger that.
This is Atlas Launch Control, T-minus 22 minutes and counting. Crews aboard the International Space Station are also awaiting the launch of the CRS-7 cargo module today so that they can continue their cutting-edge science and technology research. The larger enhanced pressurized cargo module that's being launched this morning is carrying 7,626 pounds of crew supplies, spares, and mission hardware, more than any of the previous Cygnus cargo modules launched previously. As we heard, this is the first Cygnus flight on an Atlas having aboard powered active experiments. The onboard cargo will support dozens of the more than 250 science experiments that are aboard the space station. These particular research investigations that are associated with CRS-7 are going to be occurring during the Expedition 51 mission, which is currently underway, under the command of NASA astronaut Peggy Whitson, and then later Expedition 52, which is currently planned to begin in early June. Also included with the Cygnus cargo module on this flight are 38 CubeSats, 34 of which will be transferred over to the space station for eventual deployments from the airlock of the Japanese Kibo module. And there are 4 CubeSats which are mounted externally to the Cygnus. After Cygnus departs from the International Space Station in mid-July, it will climb to a higher altitude, around 310 miles, and eject them into space. This orbital ATK CRS-7 cargo module is the 3rd Cygnus commercial resupply mission using Kennedy Space Center facilities and launching aboard an Atlas V by United Launch Alliance from Cape Canaveral Air Force Station. And we're now at 20 minutes and counting. This is Atlas Launch Control. This is Atlas Launch Control at T-minus 19 minutes and counting. The Space Coast is proud of its long tenure at the Cape and history of supplying and servicing the International Space Station, which plays a vital role in developing the research necessary for deep space exploration. NASA is committed to support a growing commercial space economy as well, and by working with our aerospace industry partners to carry critical experiments and crew supplies to and from the station. By doing that, NASA is able to focus our efforts on going yet further into space. So let's go now to NASA's Tori McClendon, who's standing by with a special guest. Tori?
Thanks, George. I'm here on this gorgeous day. I've got a great view of the iconic vehicle assembly building just over my shoulder. The crowds here are definitely ready to see a launch today. Those of you may not know that Florida Space Coast saw 23 launches just in the last year, and we expect that number to grow in the future. I'm joined here by Kennedy Space Center Director Bob Cabana. Bob, thank you for being here.
Oh, it's my pleasure, Tori. What a beautiful day for a launch.
Yes, it certainly is. So, Bob, this is the 2nd cargo resupply mission to the International Space Station this year. Can you tell us what that means for station, and how is that essential to our future?
Well, supplies to the space station are critical. We got to keep that crew alive up there. But I think one of the most important things, besides the supplies, it's the experiments that are going up. And this one is loaded. I think one of the neatest ones is the advanced plant habitat. It's an experiment right here at the Kennedy Space Center. But, you know, learning how to sustain humans in that microgravity environment for extended period of time. If we want to explore beyond our home planet, establish a presence in the solar system, get to Mars one day, you know, it's going to be critical to have a food supply other than just the prepared food that we take up. And the advanced plant habitat, it's awesome.
Absolutely. So we're working with private industry to resupply the space station, and we're also enabling commercial companies to eventually send astronauts into low Earth orbit. Can you tell us how NASA is enabling innovation through these partnerships?
Well, you know, we've been going back and forth to low Earth orbit for 50 years. We know how to do that. It's time for NASA to focus on that hard job of exploring beyond our home planet and enable those commercial operations to low Earth orbit. Nowhere is that more evident than right here at the Kennedy Space Center. I mean, we got Boeing over here in OPF Bay 3 behind us, building the CST-100 Starliner spacecraft to take crews to the space station. Out on Pad A, SpaceX has transformed that pad to support both the Falcon 9 and the Falcon 9 Heavy, also flying crews to the space station with the Crew Dragon. They've already had 3 commercial launches off that pad this year. You know, enabling those operations, it's critical to our future. And, you know, people talk about government or commercial space. It's not either or, it's and. We need both of them to be successful, integrated. And commercial is going to play a big role in supplying and helping us get to Mars.
Yes. So you mentioned Boeing and SpaceX. Tell us what it is that drives industry to the Space Coast.
Well, location for one thing. This is a prime spot to launch rockets to space here on the east coast of Florida. And, you know, then we have the facilities available. But I think it's the talented workforce that's in this area. I can't think of a more dedicated, talented workforce than right here at the Kennedy Space Center and on the Space Coast.
Yes. So, you know, NASA is driving technical capabilities and expertise. Tell us about the benefits of industry being here at Space Coast.
Well, as I said, for one thing, it's enabling this commercial partnership that we have. And we've proven here at the Kennedy Space Center that public-private partnerships work in our agreements with all the commercial companies that are moving in. You know, doing NASA work here at Kennedy, there are about 7,800 contractors and civil servants paid for with NASA dollars, but there's well over 8,000 people working here, and the number continues to grow. One of the newest additions is Blue Origin, building a huge manufacturing facility in Exploration Park on KSC property, but outside the secure perimeter, for their new Glenn rocket that's going to take humans to space from Launch Complex 36. You know, if you look at, in all of human history, 3 nations have launched humans to space: the United States, Russia, and China. But right now in the United States today, here at the Kennedy Space Center, there are 4 U.S. commercial companies building human spacecraft. Lockheed Martin building the Orion spacecraft right here in the ONC High Bay. Boeing with the CST-100. SpaceX is going to be launching right here on pad 39A, and then Blue Origin. And I think that's amazing.
It is absolutely amazing. Well, Bob, thank you so much for being here with us.
Tori, thanks for having me. Hey, go Atlas, go Cygnus.
Yes. All right, so we're very excited to see the launch today. And George, back to you.
All right, thanks, Tori. We'll be back to you in just a few minutes with another interview about what's going up to the International Space Station for the crew, particularly the science that's going to be happening. If the launch occurs at 11:11 this morning, the space station is going to be located over the English Channel off the southeast coast of England at an altitude of 255 statute miles. Once the liftoff occurs, we'll be hearing the voice of telemetry engineer Marty Malinowski from the United Launch Alliance calling the Atlas V flight events as they occur. The initial tracking data and telemetry will come from the Air Force tracking station antennas here at Cape Canaveral, and then as the rocket moves to the northeast, the Air Force tracking station in southern New Hampshire, just north of Boston, will also be furnishing data from the ground. They acquired about 4 minutes 57 seconds into the flight. And then at that point, data begins to flow from space through the TDRS East, the tracking and data relay satellite that's positioned over the Atlantic Ocean. That starts at 9 minutes 49 seconds into the flight and continues through spacecraft separation from the Atlas V, which occurs at launch plus 21 minutes. We're now at T-minus 12 minutes, 30 seconds and counting. This is Atlas Launch Control.
T-minus 12 minutes.
This is Atlas Launch Control, T-minus 10 minutes, 15 seconds and counting. NASA has been supporting and resupplying the International Space Station for nearly 2 decades. Its extended life is due in part to the world-class scientists and engineers who've done tremendous work keeping NASA's orbiting laboratory up and running. But crew supplies and spare mission hardware are not the only things headed to the station. With more on the dynamic and potentially life-changing research investigation sitting aboard the Cygnus spacecraft, we go once again to Tori McClendon. Tori?
Thanks, George. You know, you're absolutely right. The science that is soon to be on station is extraordinary. And for those of you watching at home may not know that each experiment has already been paired with the astronauts who will be conducting the research on station. I'm joined now by Dr. Tara Rutley. Tara, thank you for being here.
Good morning. It's really exciting to be here.
It definitely is.
Yes, so happy to be here from the Johnson Space Center. Looking forward to a rocket launch.
Same here. So can you tell us what makes the International Space Station such a unique platform for scientific research?
Oh, well, the obvious one is the lack of gravity. If you can think of any science experiment you've ever done in school, it's all surrounded by gravity. That's the one variable we cannot control. You take that away, different things can happen and things can get a little bit unpredictable. And we use that unpredictability to be able to study new things and then learn new things and create new experiments. So it's the microgravity component that's number one. There are many other aspects to Space Station that's special too, but that's the main one you can't get on Earth.
Thank you. So what makes, tell us about some of the more exciting findings that have been done aboard the space station.
I think one of the most exciting findings from the International Space Station is a finding that's led to an improvement of a drug that's used to treat Duchenne muscular dystrophy. That's a muscle wasting disease. Now our Japanese colleagues sent up a protein crystal structure, tried to grow that protein crystal on the space station where gravity can't interfere, and they grew it with a medicine they use now, and they just wanted to see if they would learn anything new from being able to grow large crystals. They did. They found a new hidden water molecule that had never been seen before, and they took that information down to Earth and created a more powerful drug that is in clinical trials now that could prolong the lives and the quality of life of people with Duchenne muscular dystrophy. That's amazing.
That is absolutely amazing.
But there's lots of stuff that happens that's different in microgravity. We get good results across the board, both for Earth benefits and space exploration.
So speaking of that, can you tell us about this student experiment that we've been hearing so much about, the antibody investigation that can help enable the chemotherapy?
Yes. So the chemotherapy investigation is actually not the student experiment, but it's okay. It happens a lot that the two get confused. Okay. The student experiment is going to amplify DNA to look at changes in our aging process. But the investigation used to target cancer treatment is really going to use the microgravity environment of space to grow up spherical cultures of cells. And then what they do, this group on Earth, it's a company, they create a way to target chemotherapy treatment right to only to the tumor cells. So they attach the nasty drug to what's called an antibody that can find the cell, in which case in microgravity that's a big spherical tumor. Okay. And we'll see what we get.
Well, thank you so much for sharing with us today.
You're very welcome.
Being here.
Yes.
Right. George, back to you.
Thank you, Tori. And right now we're getting ready to hit a milestone in the countdown where we'll be going into a planned built-in hold, which is 30 minutes in duration. And it comes up at T-minus 4 minutes. And at that point, that will give the launch team a chance to catch up on any activities which are open. Also as well, work any issues that are out there in the background that they'd like to have resolved before we pick up the terminal count at T-minus 4 minutes. Also, just prior to coming out of that hold, we'll be hearing our orbital ATK spacecraft test conductor Clint Combs confirm that the spacecraft is on internal power and that it's been configured for a liftoff today. At T-minus 5 minutes, 38 seconds and counting, this is Atlas Launch Control.
T-minus 5 minutes, 20 seconds.
Prop 1, LC.
This is LC go.
Yes, op 50, step 750. Fuel sequence is complete.
Roger.
T-minus 5 minutes.
Start rate SDAT acquisition.
Roger.
Atlas LO2 at flight level. Roger.
Centaur LO2 at flight level.
Roger.
Centaur LH2 at flight level.
Roger.
This is Atlas Launch Control, T-minus 4 minutes, 10 seconds and counting. Standing by to go into the planned built-in hold in 4, 3, 2, 1. T-minus 4 minutes and holding.
T-minus 4 minutes and holding. This is a programmed 30-minute hold.
Next thing coming up will be a weather briefing from our Air Force Launch Weather Officer, Todd McNamara. Cygnus will be arriving at the space station on Saturday, April 22nd, with a capture at 6:05 a.m. Eastern Time, at which time it will be located over southern France, southeast of Toulouse. Using the station's robotic arm, Cygnus will then be attached by the crew on the bottom of the station's Unity module, where it'll spend the next 3 months until mid-July, when it will unberth and depart. This is out at the Cape Canaveral National Seashore, Playa Linda Beach, where a lot of our visitors, especially for spring break, are down enjoying the excellent weather that we traditionally have here during April. This is the Mission Directors Center at the Atlas Spaceflight Operations Center of United Launch Alliance, where our mission managers are gathered and preparing to give their final go for the launch, both for the Atlas V and for the Cygnus. It's actually the Launch Control Center control room, where the majority of our United Launch Alliance Atlas team is monitoring all the systems and commanding the Atlas V rocket. And this is the Johnson Space Center in Houston, where the mission team will be monitoring the spacecraft after separation from the Atlas V through the solar array deployment, and then later on rendezvous. Our JSC mission director for launch is Zach Dwyer, who's in position there in Houston. And this is the Orbital Mission Control Complex in Dulles, Virginia, where Orbital ATK is remotely following the progress of the countdown this morning, and will be watching the Cygnus closely after separation of the spacecraft when it begins to prepare to deploy the solar arrays. And again, back live at Space Launch Complex 41 at Cape Canaveral.
Roger.
Routine
RCLC
testing of the Centaur is now wrapping up.
conference net.
Right.
And our weather briefing is next.
LC, this flight control.
Go flight control.
Are you ready to copy step 860?
Ready.
L3 primary steering file adjust underscore AV 070 underscore 05 with SDL CRC 1165 has been received, verified, and is ready to load into the Inca.
Proceed with load.
And LC 82.
Go P82.
Yeah, that was top 50, step 865.
Roger. I was just getting confirmation from Denver, and with that, we have a proceed to copy. Field 2, LC.
Go ahead.
Resume Centaur LH2 topping to flight level.
Roger.
Box 2, resume Centaur LO2 topping to flight level.
Roger.
Yes, are you ready to conduct the L-30 weather brief? I am. Copy that. LWO, please proceed.
Yes, you can see on the radar that the showers out to the northeast that were of concern have dissipated, and the ones that are further out to the northeast are starting to dissipate at this time, and we have no concerns at all with those showers throughout the rest of the window. Currently, we are go for all constraints, and we're expecting to be go for all constraints throughout the rest of the window. Are there any questions?
Questions? RC.
No questions from LD. Thank you.
Thank you, LW.
Go flight control.
Are you ready to copy on step 880?
Ready.
This is Atlas Launch Control, T-minus 4 minutes and holding. We're inside our planned 30-minute built-in hold, and we have 21 minutes, 40 seconds remaining until we restart the clock. And joining us now is Vern Thorpe, the Program Manager for Commercial Missions from United Launch Alliance. And Vern, we're pleased to have you here to talk not just about what we've done to get this Atlas V ready to fly today, but what we're going to see after the liftoff as well, so everybody will know what to watch for and what's coming. So, Vern, welcome, and if we could go ahead and roll the first tape.
Okay, thanks, George. Okay, the first video we're showing here is some of the processing activities that took place to get ready for today's launch. What you're seeing here are the Atlas vehicle stages arriving on the Mariner, which is the transport ship that we use to bring the stages from our factory in Decatur, Alabama, to the Cape. We can also deliver them to Vandenberg. When they arrive at the Cape, we bring them to the ASOC, or the Atlas Spaceflight Operations Center, for some initial checkout and processing before we go out to the launch pad. We can store several boosters in the ASOC, as you can see there. Once we're ready to go on stand, we'll bring the booster out. We'll mount it to the mobile launch platform, as you see happening right here. That operation took place, I believe, on February 22nd this year. The arrival at on the Mariner that you saw before took place on February 5th. And that was all targeted to the initial launch date that we had in March. Here you see the Centaur going on top of the Atlas, and what you actually have here is the Centaur that's already been integrated with the interstage adapter on the bottom and several of the other adapter structures that we use on top. We put all those pieces together in an offline processing facility and bring them out as a single stack to put on top of the rocket. That saves us a lot of time on the pad. And then, of course, once the two stages have been mated together, we're ready to bring the encapsulated payload fairing, the encapsulated payload out. It's been encapsulated in our payload fairing. We mount that on top of the rocket, and at that point, we just have a few integrated tests to go to get ready for launch, and we're typically just a few days from launch at that point. So those are some of the steps we went through to get ready for today's launch.
Well, that takes us to what we hope is going to happen at 11:11. Are we still tracking that liftoff time of 11:11?
We are. It's looking good right now. So I think our next video will give you a preview of what you can expect to see during today's launch.
All right.
5, 4, 3. We have Atlas ignition. 2, 1, 0, and liftoff. We have liftoff of the Atlas V rocket.
So this is our Atlas V 401 configuration. It has no SRBs. It's just a single core rocket. It's kind of the workhorse of our fleet. We've flown about 35 or 36 of these, about half of the Atlas Vs. It lifts off with almost 900,000 pounds of thrust. That booster stage will burn for a little over 4 minutes. And at that point, the vehicle will be moving at about 10,000 miles per hour, but we still have a ways to go before we're in orbit. So we will shut down the engines when we run out of fuel, and we'll separate that stage from the Centaur and the payload. And a few seconds later, we will light the Centaur engine for the single burn that we'll need today to get the OA-7 mission into orbit. A few seconds after we begin that Centaur burn, we'll separate the payload fairing, as you see there. That initial Centaur burn will last a little over 13 minutes. 13 minutes and 21 seconds is what we're predicting today. That will put us in a low Earth orbit. That's the initial orbit that the Cygnus module wants to get to. We'll coast for a couple of minutes, orient the vehicle properly for separation, and separate, as you see right there. Separation will occur slightly less than 21 minutes after launch, so this is a fairly short duration mission. Now, after separation, we'll begin a series of maneuvers to safe the Centaur and get it away from Cygnus so there's no chance of recontact. And then we're going to coast for almost another half an hour, and then we will do one more very short burn. It's about a 12-second burn, and that burn will allow us to do a controlled deorbit of the Centaur upper stage. And a little after an hour after liftoff, the Centaur will re-enter south of Australia over the ocean, over open water, and that's kind of the standard process we use these days for disposing of that upper stage, so we don't have any issues with orbital debris.
Well, Vern, that means after spacecraft separation, you still have a lot of things to follow for a while longer, while the Cygnus is getting ready to deploy its arrays.
That's right.
We've just had confirmation from Orbital ATK, from Clint Combs, the test conductor, that Cygnus is being transitioned to internal power, so that's keeping everything right on schedule. So at this point, we're still standing by for an 11:11 liftoff. So we are T-minus 4 minutes and holding This is Atlas Launch Control.
LC, this is Redline Monitor.
Go Redline Monitor.
Roger, I understand the switching is complete. I've reset and Redline Monitor is green and active.
Roger, I was just informed by ASC, so as correct state. And FTS LC.
Go ahead, it's FTS.
Yeah, Operation 50, Step 700. Are we able to call that complete now that troubleshooting is complete?
Yeah, we can call that incomplete.
Roger.
This is Atlas Launch Control, T-minus 4 minutes in holding. We're in our planned 30-minute built-in hold at this point, which picks up once again at T-minus 4 minutes. As we heard, the orbital ATK Cygnus cargo module is an 8-ton unmanned cargo vehicle, essentially a space freighter, which has been built in Italy, and the service module built in the United States by Orbital ATK. And the Atlas that it's flying on is actually the same derivative of the one John Glenn flew into space during the Mercury program in 1962. And then atop the Atlas, giving the final boost to the cargo module, is a Centaur high-energy upper stage, which was originally developed by NASA. Cygnus is going to be resupplying the crews on the space station with clothes, food, water, and equipment, and all of the commodities that the astronauts need to live and work in orbit. And then in addition to that, all of the experiments that will be keeping the crews busy. The Cygnus is going to arrive at the space station on Saturday, April 22nd, with a capture at 6:05 a.m. Eastern Time, where it will remain attached to the Unity module until mid-July, when it will unberth and depart, and the current planned re-entry date is July the 25th. Our countdown channels are relatively quiet right now. We're not working any significant issues that would preclude a liftoff at 11:11 this morning. Very shortly, we'll hear our United Launch Alliance launch conductor Scott Barney come on and poll the team for their readiness, and we'll get a final go from ULA's launch director Bill Cullen. Once the Atlas lifts off, it'll be on an azimuth of 44.4 degrees, and the orbital inclination, once the Cygnus is in orbit, will be 51.6 degrees, same as the space station, and the orbit at separation will be 124.2 nautical miles.
Indicated that if for some reason they cannot proceed with launch on the 1A transmitter either side, they would be switching to the 1 Bravo side.
This is Atlas Launch Control, T-minus 4 minutes and holding. And once again, we're pleased to announce today that for the first time you can view this rocket launch in 360 degrees. This is not just for virtual reality viewers with 360 headsets, but anyone that's interested in gaining a panoramic view of the launch straight from their own smart device or their own personal computer at home. As you can see here, you can manipulate the video on the screen, virtually placing you closer to a live rocket with a 360-degree view, just a few feet away from the Atlas rocket as it's lifting off. So it's an easy stream to find. Just go to www.youtube.com/NASA Television and then just click on the associated Live Now link. And something we'll be using for future launches as well. The Atlas V that we've got on Space Launch Complex 41 today is a two-stage rocket, as we've heard, an Atlas and a Centaur. Here we see those being stacked into a 14-foot diameter payload fairing. 7,626 pounds of NASA cargo on board. It's the fourth flight of the enhanced Cygnus. And it's 21 minutes from the time the Atlas lifts off until it's in low Earth orbit. We're at T-minus 4 minutes and holding. This is Atlas Launch Control.
L minus 10 minutes.
CMD, LC.
This is Atlas Launch Control. We're approximately 10 minutes from launch. All things on schedule for an 11:11 a.m. liftoff. I would like to welcome those of you just joining us now on Facebook Live and 360 Stream. At this point in the countdown, we're about to hear the final poll of the launch team for coming out of the T-minus 4-minute built-in hold. And that will begin the terminal countdown. And the Atlas and the Centaur stages of the Atlas V will go on to internal power. The Cygnus cargo module just a short time ago was placed on internal power and put into the launch configuration. The weather is green.
That is check. The observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
Scott Barney briefing his final briefing to the launch team.
LCSTS.
Go.
Davis Systems, cameras configured for launch.
Roger. OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Red line monitor and event table are in the correct configuration for terminal count.
Roger.
Launch on time verified.
Roger.
Weather is go. We'll get a final go from the range at L-1 minute. "15 seconds from coming out of the hold."
On my mark, the time will be T minus 4 minutes and counting. 3, 2, 1, mark.
T-minus 3 minutes, 55 seconds.
Ground pyros enabled.
All the status boards right now in the Launch Control Center showing green. T-minus 3 minutes and counting.
That was thanks to flight.
2 minutes, 50 seconds.
FTS internal.
Securing L2 topping.
Gyro's going from manual to automatic at this point on the rocket. At 25 seconds, we'll get a final go from the launch team.
T-minus 1 minute, 59 seconds.
Vehicle internal.
55.
On sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
Countdown now on
140.
automatic.
Launch enabled.
137.
FTS armed.
130. 120.
OCUs armed.
STS count started.
115. 110.
Vent valves blocked.
T-minus 1 minute.
Rock, report range status.
Range green.
54.
Range is go, including weather. Final go pulled at 25 seconds.
40.
Stable at step 3.
T-minus 30 seconds.
28. 25.
Status check. Go Centaur. Go OA-7.
20.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn extending the research legacy for living and working in space.
Speeds, injector pressures look good. HER roll program has begun. Body rates look good. Booster engine continues to look very good. Pump speeds, injector pressures in band. D180 continues to perform well. Now requesting an mixture ratio change. Booster has begun the zero angle attack phase of flight. Pictures look good. Body rates are right down the middle. RD-180 performance continues to be nominal. Mach 1.
Vehicle now going through the sound barrier.
Max Q. Body rates continue to look very good at this point in flight.
Vehicle hitting maximum dynamic
Booster has
pressure.
throttled back, right on schedule. Signatures look good.
Engine throttle
Current
back going through
altitude
max
is 11
Q
miles.
as customary.
Range distance is 5.5 miles. Current velocity is 1,929 miles per hour. Range track shows good progress right down the middle of the corridor. Booster engine performance continues to look very good at this point. EU control is near nominal. Body rates look good. Steering has been enabled at this point. Body rates look good. The vehicle is now 1/2 of its liftoff weight.
Two and a half minutes
The
into the
alpha
flight.
steering has begun. Body rates look good. And we've fired the RCS pyro valve. That system is now pressurizing to flight levels. Signatures look good. Current altitude is 29 miles, downrange distance 39 miles, current velocity 4,325 miles per hour. Booster has begun to throttle to maintain 3.5 Gs. Closed loop steering has begun. Body rates look good. Vehicle is now 1/4 of its liftoff weight. RD-180 continues to perform well. Mixture ratio looks good. Boost phase chill down has begun. And boost phase chill down has completed. Went up on Pico momentarily. And we have Pico. Engine shutdown looks good. We have stage separation. We have LOX and fuel pre-start. We have ignition and full thrust on the RL-10. Payload fairing jettison has occurred. Looks like a clean step. Centaur steering has been enabled. Body rates look good.
Data now coming in from the New Hampshire tracking station.
Miles, downrange distance 317 miles, current velocity 10,000 feet. 50 miles per hour.
Still data coming in from the Cape as well.
Centaur PU is requesting an oxidizer-rich condition at this point. Chamber pressures, LOX pump discharge, and venturi are within band. Hydrogen system line temperatures are warming towards bottle temperature.
Ready.
And we have a quick report of Atlas first stage performance. It was plus 106 pounds of PE or 0.33 sigma high. We have begun seeing our thermal conditioning fairings on the RCS. Now controlling near nominal mixture ratio also. Engine response looks good. Set MR.
Centaur now steering and powering the rocket.
Centaur is completing the dogleg maneuver. Body rates are now controlling down the middle. Dogleg is complete. And Centaur has begun to roll to optimize telemetry. RL 10 chamber pressures, LOX pump discharge, and fuel venturi all look good.
7 minutes into the flight now.
Centaur currently is flying at an altitude of 191 miles. Downrange distance is 685 miles. Current velocity 10,538 miles per hour. This first burn of Centaur is scheduled for 13 minutes and 42 seconds in duration. All systems continue to look very good at this point. Continuing to observe our thermal conditioning firings on the RCS. Signatures are normal. Centaur has completed the roll to optimize telemetry. Going right down the middle at this point. Range track shows good progress down the expected corridor.
About another 10 minutes on the Centaur burn. Centaur cuts off at 18 minutes into the flight. We're just over
Centaur
8.
fuel limiting has completed. Now actively controlling MR. Still near nominal at this point. Centaur tank pressures, bottle pressures are all stable. Battery voltages look good. Centaur currently is flying at an altitude of 219 miles. Downrange distance 1,024 miles. Current velocity 11,250 miles per hour.
Nine and a half minutes into the mission. Seven, 6, 5, 4, 3, 2. Go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space. Seven, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
U.S. close-up controls, which is good. Pump speeds, injector pressures look good.
4, 3, 2, go for main engine start.
Booster engine continues to look very good. Pump speeds, injector pressures in band. The 180 continues to perform well. Now requesting the mixture ratio change. Booster has begun the zero angle attack phase of flight. Pictures look good. Body rates are right down the middle. RD 180 performance continues to be nominal. Mach 1.
Vehicle now going through the sound barrier.
Max Q. Body rates continue to look very good at this point in flight.
Vehicle hitting maximum dynamic
Booster has
pressure.
throttled back, right on schedule. Signatures look good.
Engine throttle
Current
back going
altitude
through
is
max
11
Q
miles.
as customary.
Range distance is 5.5 miles. Current velocity is 1,929 miles per hour. Range track shows.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
U.S. controls. Pictures look good. Speeds, injector pressures look good. HER roll program has begun. Body rates look good. Continue to look very good. Pump speeds, injector pressures, and band. The it continues to perform well. Now requesting the mixture ratio change. Has begun the zero angle attack phase of flight.
Seven, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
The U.S. going to close loop controls. Signatures look good. Bumper speeds, injector pressures look good. HER roll program has begun. Body rates look good. Booster engine continues to look very good. Pump speeds, injector pressures in band. The 180 continues to perform well. Now requesting the mixture ratio change. Booster has begun the zero angle attack phase of flight. Signatures look good. Body rates are right down the middle. RD 180 performance continues to be nominal. Mach 1.
Vehicle now going through the sound barrier.
Max Q. Body rates continue to look very good at this point in flight.
Vehicle hitting maximum dynamic
Booster has
pressure.
throttled back, right on schedule. Signatures look good.
Engine throttle
Current altitude
through
is
SQ.
11 miles.
Eight, 7, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
The U.S. going to close loop controls. Signatures look good. Bumper speeds, injector pressures look good. HER roll program has begun. Body rates look good. Booster engine continues to look very good. Pump speeds, injector pressures in band. The 180 continues to perform well. Now requesting the mixture ratio change. Booster has begun the zero angle attack phase of flight. Signatures look good. Body rates are right down the middle. RD 180 performance continues to be nominal. Mach 1.
Vehicle now going through the sound barrier.
Max Q. Body rates continue to look very good at this point in flight.
Vehicle hitting maximum dynamic
Booster has
pressure.
throttled back, right on schedule. Signatures look good.
Engine throttle
Current
back going
altitude
through
is
SQ
11
as
miles.
customary.
Range distance is 5.5 miles. Current velocity is 1,929 miles per hour. Range track shows good progress right down the middle of the corridor. Booster engine performance continues to look very good at this point. EU control is near nominal. Body rates look good.
2, go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
Controls look good. Bumper speeds, injector pressures look good. HER roll program has begun. Body rates look good.
Eight, 7, 6, 5, 4, 3, 2, go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
Controls look good. Bumper speeds, injector pressures look good. HER roll program has begun. Body rates look good. Booster engine continues to look very good. Pump speeds, injector pressures in band. D-180 continues to perform well. Now requesting an mixture ratio change. Booster has begun the zero angle attack phase of flight. Pictures look good. Body rates are right down the middle. Our D-180 performance continues to be nominal. Mach 1.
Vehicle now going through the sound barrier.
And we have Pico. Engine shutdown looks good. We have stage separation. We have LOX and fuel pre-start. We have ignition and full thrust on the RL-10. Payload fairing jettison has occurred. Looks like a clean step. Centaur steering has been enabled. Body rates look good.
Data now coming in from the New Hampshire tracking station.
Miles, downrange distance 317 miles, current velocity 10,050 miles per hour.
Still data coming in from the Cape as well. Seven, 6, 5, 4, 3, 2, go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space. Seven, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
The U.S. going to close-up controls. Just good. Pump speeds, injector pressures look good.
This is Atlas Launch Control. We're now at a mission elapsed time of 1 hour, 30 minutes, 43 seconds. And all of the activities on board the Cygnus continue to go well in preparation for the solar array deployment. But right now joining us is our Center Director, Bob Cabana, Director of Kennedy Space Center. And I think, first of all, Bob, you got to watch the launch live and up close. What was your thought as it went
Absolutely,
off?
George. You know, I was going to ask you, do you ever get, feel kind of like secluded in the booth all the time, never getting out to see
You
them
never
live?
get to see a launch.
I know.
I was trying to figure out the last time I actually was outside and saw one that was somehow involved in the countdown for in some way. And but I remember a long time ago, Jim Womack, who was our director of expendable vehicles, way back a long time ago when he retired, and he worked all the way back to Alice in the Mercury days, and he'd never seen a launch. He was always in the blockhouse.
So
when he retired, he said, "This is the first time I've ever seen a launch." When he was
so it was an awesome launch. It was just what a beautiful day for a launch, and the atmosphere, everything, it was great. We were over in OSB2 with the VIP guests. I miss sitting on console. I miss having something, being involved and seeing the data
because this is the
more
fun,
real time.
Fun part, really.
But it was a beautiful launch. The guests loved it. Absolutely special. The first shuttle launch that I saw was mine. I never got to see a shuttle launch before I actually got to launch on the shuttle. At the time, I was the Deputy Chief of Aircraft Operations at the Johnson Space Center. And the Chief of Aircraft Operations, Joel Granny, he always flew over to support the launch at the Cape, and he left me behind to run everything at JSC. And then when I got into training, I didn't have time to get over and actually see a launch. But, I always tell folks, don't take pictures. You got to experience it. It's an emotional thing, and watching it through the viewfinder of your camera, it just doesn't do it justice. You need to feel it, sense it, hear it, experience it, and anytime a rocket ship leaves planet Earth, it's special. And this one, excellent launch today. ULA, another great job with the Atlas V and Orbital ATK, the Cygnus vehicle. Looking forward to getting the solar arrays out, but performing well, and some really critical supplies for the International Space Station.
Well, we had noticed we had some coverage from the beach, and the Canaveral National Seashore really had a big turnout today. They were able to.
I was talking to somebody, and they said the roads around KSC, it was like during the shuttle days as far as the traffic and everything with the number of people, and that's the kind of excitement that space brings. But you're no stranger to that. So, George, you've been doing this for 36 years, 33 years with NASA and 3 as a contractor, right?
No, 4 as a contractor.
4 as a contractor.
4 as a contractor,
right.
and
37
32,
years.
Yes, it's 37 years. That's
so
right. So
your first launch was an Atlas off Launch Complex 36, right, that you did commentary on?
I think it was an Intelsat. It goes back far, and I can't quite remember for sure, but I think it was an Atlas off 36A, and I think it was an Intelsat.
And you did all the Hubble servicing missions, right?
I did the Hubble launch plus all 5 servicing missions. So.
And you did the very last shuttle, STS-135 Atlantis.
Correct. Right.
So, I mean, you have had quite a history. And I don't know if folks know, but George is retiring. This is George's last time to actually do launch commentary live on console. And George, I don't have the gift with me now, but I just want to say thank you for all your years of service and the outstanding job that you have done with launch commentary for NASA and our nation. You're absolutely outstanding, George.
Well, I appreciate that. It's so much fun. I mean, and I can't think, when I started out on my career here, I can't really think of very much that I haven't been able to do that I wanted to do, and that's what's really made it great. And it's certainly been fun. But now I've hit the point when you can't even remember what the first launch was. It's back away. I remember my first space shuttle one, but I'm not sure I remember my first launch.
So that was back in 1986, wasn't it? STS-28.
27. Yeah, I did 27. That was the Department of Defense mission, and they put me on that one because you couldn't say anything much anyway, since it's a secret launch. So they knew I wouldn't blow that one. So that was going to be that was my first one.
So George didn't know I was going to recognize him today, but I could not let this opportunity pass. You've just done an outstanding job, and we're really, really going to miss hearing your golden voice on console during launch, George.
Well, thanks so much, and I'm sure when I'm retired and up in the mountains somewhere, when there's a launch going, it'll be hard not to tune it in some way on satellite radio or something to see it, because
it's kind of in your blood, isn't it?
Well,
it's hard
hard
to get rid of it.
You can take the boy out of the launch, but you can't take the launch out of the boy. So that's probably the way I'm going to be after I retire.
I'm with you. I agree.
So yeah, it's certainly fun, and but I think for me the highlight has been when I look at all the different kind of spacecraft missions, payloads that I've had a chance to work. That's really been the highlight for me, and the launch is fantastic, because that's how we get the mission going. But the mission itself, some of these spacecraft, I mean, to be within 5 feet of something that's going to another planet, I mean, to me, that is really exciting.
It's really cool.
Yeah.
I was in the clean room with the Curiosity rover before it launched on an Atlas V to go to Mars, and now that thing's running around on Mars, and to say, hey, that's really cool. I'm with you.
Yeah, and so now we've got Cassini getting ready to re-enter, and I was part of that and up close with the spacecraft, and it just when you think back on the launch, you can definitely remember the launch, but then when it gets to the planet and you think, I was part of
history,
working with the test team to get that ready to go.
So you've seen a lot of change at the Kennedy Space Center in your time that you've been here doing launch commentaries and stuff.
Well, I think for me it was the change in the direction that the shuttle program eventually took, from where we were launching a lot of different things, both our NASA missions that were planetary, things that to commercial flights, launching satellites, all of that kind of thing, and then we reoriented ourselves to constructing the space station. But when you think about it, the history of the space shuttle program, it did everything it set out to do. I mean, did it launch as frequently? No. But did it do what the things that we needed to do, that NASA needed to do? It did, and I think there will be whole books written about what shuttle did, just
absolutely.
like there will be whole books written about the way the moon program.
Sure.
I think when you look at the diversity of the missions that shuttle did, and it was the only thing that gave us that kind of capability, and I don't know when we'll ever see that again next. So.
Well, you talk about diversity. One of the things that I say about the space shuttle, one of the most important contributions was it brought diversity to America's space program. If you look at prior to the shuttle, Apollo, Mercury, Gemini, it was white military test pilots with a few scientists thrown in at the end, and the shuttle opened the doors from the 5th percentile female to the 95th percentile male. And that 78 class, that first class of shuttle astronauts, there were men, women, black, white, Hispanic, Asian, military, civilian, and it was opened the door to space for everybody.
Yeah, and our international partners started participating with it. So it's just all kind of carried through to what we're doing now.
So how about the latest direction at KSC with the shuttle retired now as we move into this, public-private partnerships enabling commercial operations, and still working on SLS and Orion to get us beyond planet Earth?
Well, I think my thought on it is the commercial aspect is kind of a logical evolution for us at this point. But if I look, if I was going to be here another 15 years, what would I like to work on? And the space launch system is very attractive,
Isn't
very
it?
tantalizing.
We are going. I mean, I look at the infrastructure that we're putting in place, and I look at the crawler transporter that has been upgraded to support the heavier weights and everything. I see the high bay. I see the mobile launcher. I look at the launch pad that's going to be complete here in August, and I say, that mobile launcher, that crawler transporter, it's going to roll out that pathway to Pad B. It's going to take us to Mars. That's going to be the beginning of an awesome trip, when it rolls out of the VAB with that rocket on it. That is just amazing to think that we're actually enabling that.
And, I kind of experienced that when we were first getting ready for shuttle, and we did a lot of these things to get get the shuttle ready, to get the vehicle assembly building ready. When we had our first rollout, I think it was on the 4th of July, if I'm not mistaken. But at any rate, that it's the same kind of thing we'll go through with Space Launch System. It's, you know, I could start my whole career over again.
I can't wait. I'm with you. I can't wait. I'm not dead yet. I got a few more years left. Now I'm hanging in there. I want to see this.
Yeah. So FLS would be fun. So.
Thank you for having me on console with you.
Thank you.
It's
very
always
much
a
for coming
pleasure
over.
and an honor. It's one I'm going to remember. I got to speak with the George Diller. Thanks, George.
Thanks so much. So and it's been fun, you know, for this mission, you know, to go out on this one. You know, working with Orbital ATK is just wonderful because they are so oriented toward their mindset toward getting the message out that we're trying to convey about what we can do in space and how commercial space can contribute to that.
Agreed.
So they've been wonderful to work through all the way through these ones that they've done down here at the Cape. So so I'm glad I'm going out on this one.
I know.
Right. All right. Thank you very much.
Thank you, George.
Bob Cabana, our Center Director at Kennedy Space Center. And we're now at a mission elapsed time of 1 hour, 41 minutes, 30 seconds. This is Atlas Launch Control. This is Atlas Launch Control. We're now at 1 hour, 47 minutes, 24 seconds into the mission of the CRS-5. And the module on orbit is just about to come out of a planned or expected blackout period, and we'll get some status. But at 100 minutes after launch is when the initial sequence begins for the solar array deployment, in that the mechanism is warmed up. They begin to warm up the mechanism and the displays. So the CRS-7 should be sending us back some data on that reasonably soon. And then approximately the deployment will start at L plus 120 minutes, L plus 2 hours, and take about a half an hour to complete. So right now, as we get our first contact with the Cygnus module, we'll know that some of this activity, which is pre-programmed into it, is getting underway. Meantime, the spacecraft is exactly where it was expected to be, planned to be. And for that reason, the Atlas V really did a very, very accurate job of putting OA-7 on the right trajectory toward the International Space Station, which it will rendezvous with on Saturday about 6:05 Eastern Time in the morning. So we're now at 1 hour 48 minutes, now 1 hour 49 minutes into the flight. This is Atlas Launch Control. This is Atlas Launch Control, 1 hour, 53 minutes, 39 seconds into the mission. We'll look briefly at a short video of some of the cargo that's on board the CRS-7 Cygnus module that's headed for the space station.
Components of NASA's newest plant growth chamber, the Advanced Plant Habitat, will be delivered aboard Cygnus. The habitat will integrate new technology to increase overall efficiency, reliability, and robustness of plant growth on the space station. The experiment will build on the success of NASA's Veggie, which was the first fresh food growth system on the station. Cygnus will also deliver a fleet of 66 CubeSats to the space station, including 28 from different universities around the world. They will be launched from the NanoRacks CubeSat deployer on the station. Among the tiny satellites is a science payload known as IceCube, which will provide data to scientists to help them understand ice clouds and their role in climate change. Genes in Space is an annual contest for students in 7th to 12th grades. Managed by the crew on the space station, this year's winning idea for Genes in Space 2 will investigate the dynamics of telomeres, the critical protective caps on the tips of chromosomes, as a way to understand the aging process. Stresses, such as those experienced by astronauts in space, could lead to irregular regulation of telomere length, which has been linked to cardiovascular disease and some cancers. Spacecraft Fire Experiment 3, or Sapphire 3, is a third flame investigation to use empty Cygnus resupply vehicles after they leave the space station and re-enter Earth's atmosphere, providing a unique environment for studying fires and microgravity. The experiment will help our understanding of how fires spread and designing flame-resistant materials to prevent fires in space. The biomolecular sequencer experiment will demonstrate for the first time that DNA sequencing is feasible in an orbiting spacecraft. A permanent DNA sequencer could identify microbes, diagnose diseases, and monitor crew member health. In the future, it could also help detect DNA-based life elsewhere in the solar system.
And we're standing by now for our first contact as the Cygnus module comes out of its communications eclipse and gets some idea as to where it stands in terms of starting the warm-up of the deployment mechanism and the arrays themselves, which will begin at about 1:11 Eastern Time at 2 hours into the mission, and then they will take about 30 minutes to complete the deployment sequence. So at this time, all continuing to go well as we wait our first contact with Cygnus that we have available to us through our communications onboard systems. And we're 1 hour, 57 minutes into the flight. This is Atlas Launch Control. This is Atlas Launch Control for 1 hour, 59 minutes into the mission of the CRS-7 spacecraft, which is still in a communications eclipse. It should be coming out in about 6 minutes, but we do have some indication already that the warm-up sequence for the arrays and the mechanism has started, but we'll get some real hard data here very shortly. But at the moment, everything appears to be going exactly as programmed. So at 1 hour and 59 minutes, 35 seconds and counting, we'll be back with more information as soon as we've heard back from Cygnus. This is Atlas Launch Control. This is Atlas Launch Control, 2 hours, 15 minutes into the mission. At this point, our status on the solar array deployment is that both of the arrays are released, but they have not begun to unfurl yet. One of the arrays should be beginning to do that very shortly, but we're going to be losing contact temporarily through the tracking and data relay satellite, and as soon as that comes back, we should have some indication that the unfurling of one of the arrays has started. The release indicates that the arrays are positioned, and the warm-up sequence for that went well, and once the arrays finish their warm-up sequence completely, then they will begin to unfurl, and one of those is very close to that. So at this point, the deployment process is beginning. It's in work. They are both out but not unfurled, and we're waiting for the first one to begin unfurling very shortly. So far the data that they've seen indicates the process is going as planned. So we're now at T-minus 16 minutes, 15 seconds into the mission. This is Atlas Launch Control. This is Atlas Launch Control, 2 hours, 20 minutes, 40 seconds into the mission. We're back in contact with the CRS-7 module through the tracking data relay satellite, and the data we've received indicates that one of the arrays is now fully deployed. So we will be watching for the data indications that the second one has also unfurled, but one of them is out. And at this point, no indication that anything is amiss, so we're just standing by in the natural course of events for the next array to also unfurled. 21 minutes, 20 seconds into the flight. This is Atlas Launch Control. This is Atlas Launch Control, T plus 2 hours, 30 minutes, 23 seconds into the flight of the Cygnus spacecraft. And joining us right now is Frank DeMauro, the Vice President and General Manager for the Advanced Programs Division for Orbital ATK's Space Systems Group at Orbital ATK. And Frank, welcome back. And first of all, I think you have some news to impart.
Yes. We had, after a tremendous launch by the Atlas V rocket to a perfect orbit, we have a very healthy spacecraft, and we just completed the deployment of both solar arrays on the spacecraft. So we'll continue to go through the detailed checkout process, but we have a healthy spacecraft, deployed arrays, full power, and we're ready to get on with the mission.
So they're actually already generating some power at this point.
They are, yep.
So what's next coming up for the Cygnus?
We'll spend the next couple of hours just doing some detailed checkout and telemetry review, make sure all the systems are working as expected, and then we have our first big orbit raising burn in about 3.5 hours from now. So we'll start the trek from the 230-kilometer orbit we're in now to up towards the 400-kilometer space station orbit. And we'll do several burns over the next few days and be there on Saturday morning.
Right.
Yeah.
All right. Well, Frank, thank you very much, and congratulations on a very happy mission. And we're going to have some fun watching all of this over the next couple of months.
Thanks very much, George. Appreciate it.
And unload the module. So we do expect to have a news conference at 2:30 p.m. Eastern Time to wrap up our coverage, and at this point this will conclude our launch coverage of the Cygnus CRS-7 mission, and we'll be back with the post-launch news conference to pass along all of the information from the countdown and launch in the Cygnus at that 2:30 p.m. briefing. So at 2 hours, 32 minutes, 30 seconds, and in mission elapsed time, this is Atlas Launch Control. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
Good. Pump speeds, injector pressures look good. HER roll program has begun. Flight rates look good.